At least it's not that much. Okay, so that's why I look every now and then to make sure it's on. Okay, so the shape we know the shape of a quadratic function. It either opens upward or it opens downward. In both situations, we did not name this point, but obviously this is a minimum and this is a maximum, but both are called vertex. It doesn't matter if it is a minimum or a maximum, it's called a vertex. One of the things that we have not really discussed before is that each parabola, and we know that, but we haven't discussed this, each parabola or parabola, they're called parabolas, of course. So the graph of a quadratic function is called a parabola. Only the graph of a quadratic function is called a parabola. No other function. And no other function has a vertex, just the quadratic function. So what we need to remember is, and we haven't talked about that, is that the vertical line going through the vertex is the axis of symmetry. We're going to get to that in a minute. So I'm not talking about a fact that the function could be odd or even. No, no. I'm only saying that wherever it is, it will have a vertical axis that is the axis of symmetry, and it goes through the vertex. It's a vertical line that goes through the vertex. So how do I identify the shape without graphing it first? Well, if the leading coefficient is positive, we know x squared looks like this, and the leading coefficient is positive. So if the leading coefficient is positive, we're talking about a minimum. If the leading coefficient is negative, we're talking about a maximum. So coming back to our case, what does that mean? Does the parabola have a minimum or a maximum? Yes. So in our case, A is 1. So the parabola has a minimum. In step number 2, we have to determine the vertex, which is this point, extremely important point. So vertex is a point on the coordinate system. And if you allow me to go back to the quadratic formula, only because I want to make a point. And the point is, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. So why do I need this? Well, I would like you to connect the x-coordinate of the vertex, which is this. So the x-coordinate of the vertex, once you remember the quadratic formula, I'm assuming that you will never forget that the x of the vertex is this piece, what is outside of the square root in the quadratic formula. So let's find it for our function, negative b over 2a. The minus has to be right in front of the fraction line. I'm sorry, my marker kind of has a mind of its own. Okay, so negative. What is b in our situation? Any questions? What is b? Negative 6, very good. And how much is 2 times a? Very good. 2 times 1, which is a, which is 2. Good. So then the answer is? Very good. So the vertex has the x coordinate 3. Now I'm asking you, how do I find the y coordinate? Plug in 3. Of course. So this is here f of negative b over 2a. So I have to plug in 3, and I have to find f of 3. Very good. So this is 9 minus 18 plus 8, which is negative 1. So the coordinates of the vertex are 3, negative 1. Any questions so far? Any questions? Okay, in number 3, step number 3, X-intercepts, of course, comma, if they exist. What does that mean if they exist? So here's what I would like to discuss for a moment. For a quadratic function, there are three possibilities for a minimum. This is one possibility. Here is another. And here's the third one. The question is, how do I know which one I'm facing? Here's the reason why I'm asking that. Because if they don't exist, I don't want to waste my time. I'm going to say they don't exist, and I move on to number 4, which is the y-intercept. So obviously here, the minimum value is what type of number? Positive, which is not the case. Here, the minimum value is 0, which is not the case. So obviously the minimum value is a negative number because the vertex is found below the x-axis. So in our situation, it's not this, but this. And yes, the two x-intercepts are distinct and they exist. How do I determine them? So then I have to spend the time and find them. How do I determine those? For good. So then y equals 0, or x squared minus 6x plus 8 equals 0. Yes. So x minus 2 and x minus 4. And then we want to find the two ordered pairs. 2 comma, perfect, and 4 comma 0. So from here, we have two options, x equals 2 and x equals 4. Is this okay? Yes? Please ask any question, anytime. Can you follow? Is this okay? Perfect. Please stop me if you have questions anytime. Okay, so we just reached step 4. And in step 4, I need to find the y-intercept. And there is no comma if it exists. The y-intercept would always exist. And this time, yes, I have to plug in 0, and I get 0, 0, 8. And what is the ordered pair? Very good. Okay, 5, 6, and 7 are just words, but important words. Axis of symmetry. Look at the vertex. Remember, the vertex is 3 comma negative 1. And imagine the vertical line going through the vertex. 3 comma negative 1, the vertical line going through the vertex. Which one is it? It cannot be y. A vertical line cannot be y. X equals 3 indeed. X equals 3 is the axis of symmetry. Awesome. So now, since this has a minimum value is the location of the minimum is at 3, but the minimum value is excellent. Well done. We've done that a long time ago. Good. So now the range. And you can say I haven't graphed the function, but you know the range. We haven't graphed it, we haven't looked at it yet, but we know the range. Of course. Because it has a minimum at negative 1, it starts from negative 1 to infinity. Well done. So now we're ready to put everything together now. And graph it. We always start by graphing or plotting the vertex. Let's do that. Which is 1, 2, 3, negative 1, right here. The next step must be the axis of symmetry, which is not part of the graph. It will not be a solid line. It just helps us keep the graph in shape. There's nothing else. It doesn't have any other information to give us. Okay, then 2 and 4, of course they have to be symmetric, left and right of the axis of symmetry. That's why this is the axis of symmetry. And then we have 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Please graph it so it's not too acute at the vertex. So this is the graph of f of x equals x squared minus 6x plus 8. And of course it has no secrets. We know everything about it. We know it's decreasing between negative infinity and 3, and it's increasing between 3 and infinity. And yes, my graph is far from being perfect, but if I fold the graph on the axis of symmetry, as you see, does not match perfectly. I can graph 100%. But the axis of symmetry, all these points at the same height should be at an equal distance from the axis of symmetry. Let's look at a word problem, and then I'll come back to the other shape. And it's not the other shape, it's another presentation. So we want to apply something like this, a model that is quadratic in a word problem, and let's see how we do with this. Okay, so here we have a ball is thrown upward and outward from a height of 6 feet. The height of the ball, f of x, is this function. Can be modeled by this, where x is the ball's horizontal distance in feet from where it was thrown. Now, what type of function is this? Excellent. Does it have a max or a min? Correct. And it makes sense. So if assuming I have a ball in my hand and I want to throw it, this is what is going to happen. You saw the trajectory. It's going to a maximum and it eventually will hit the ground. Okay, perfect. So let's copy the function and see what we are asked to find. And this is a quadratic trajectory of the ball. Okay, so this is problem 60 on 361. And we have f of x equals negative 0.8 x squared plus 3.2x plus 6. Okay, everything is measured in feet, so this is horizontal distance in feet. This is vertical distance. I should say height. I should not write vertical distance, but you know what I mean, height. Of course, in feet. First question. What is the maximum height of the ball and how far from where it was thrown does this occur? So I throw my ball up in the air, it reaches the maximum. I need to know this distance where it reaches the maximum and how high it goes. So what would you recommend we do? Find? Of course, the vertex is the key. So in part A, find, in other words, the vertex. Great, excellent. How do I do that? Great job. Negative b over 2a, negative. Can anyone give us b? Excellent. Can anyone give us 2 times a? Two times a. Yeah. So the answer is 2. Very good. The answer is 2 feet, so this is 2. Great job. So I throw the ball here. I'm standing. I'm throwing the ball up and upward and outward. And 2 feet from where I'm standing, it reaches its maximum. But now I want to determine the maximum. How do I get that maximum? Yes, of course. So f of 2 will be negative 0.8 times 4 plus 3.2 times 2 and plus 6. So negative 3.2 plus, this is 6.4 plus 6, 3.2 plus 6, 9.2 feet. Any questions so far? So Can anyone give us the y-intercept of this function? 6, very good. So if I want to graph this function, so this is x and this is y, 1, 2, 3, 4, 5, 6. Then the vertex 6, 7, 8, 9, and a little bit. So this is the vertex, and this, one more time, 2, 4, 6, correct, is the y-intercept. Part B. How far does the ball travel horizontally before hitting the ground? What am I asked to find now? Excellent. X-intercepts. So I get when y equals 0, I copy the function, negative 0.8x squared plus 3.2x plus 6 equals 0. I refuse to solve a quadratic equation with a negative leading coefficient, and so should you. So 0.8x squared minus 3.2x minus 6 equals 0. And now let's take a moment and solve the quadratic equation. How? Correct. I was trying to be funny and ask, are you going to complete the square? But that would have been horrible. Okay. So this is 3.2 plus or minus the square root of 3.2 squared minus, but there is another minus, so plus 4 times a times c divided by 2 times a, which is 1.6. I want to show this with a graphing calculator. We may have done this before, but that's okay. Let's do it again. Do not forget parentheses. If you put it in the graphing calculator, do not forget parentheses around the numerator. The denominator does not need parentheses because it's just one number. I will also put parentheses under the square root because that's me. Your calculators are more sophisticated than I am, and they probably don't need graphing parentheses, but I insist. So the left parenthesis, 3.2 plus the square root, parentheses, because that's just me, 3.2 squared. I just don't trust that it's doing the right thing, so that's why I can't. So 4 times 0.8 is 3.2. You don't have to multiply. You can put everything in there. And times 6. Close the parenthesis. Go outside. Close the parenthesis. And divide by 1.6. Press Enter. We get 5.39. I copy everything with second and entry. Let me know if you understand that, and I'll explain. And it's easier for you with the calculator to go back and override the plus into minus. It's more difficult for me here with this software. Stop. Okay, it stopped. So negative 1.39 and 5.39. So Becca, with that one, you have to put parentheses under the square root.
Yeah, I just did it.
Yeah, all of probably does not need to. On that one is newer than yours. I have something like that, so I put parentheses everywhere. Okay, so we have two solutions here. X equals negative 1.39 feet, and x equals 5.39 feet. Of course, this doesn't make sense, but I know where it is. It's right here. And I know where this one is, 2, 3, 4, 5, and 3, 9. So this is the graph. And of course, if I were to continue, but that there is no need for that because x cannot be negative, I would have, a function would have crossed the x-axis exactly at this point, negative 1.39 comma 0. Of course, if you want to be correct, you will graph the axis of symmetry, which is x equals 2. So this is a perfect model for the quadratic, perfect example for the quadratic function model. Any questions on this? Now let's go back to the other possibility. The other possibility is f of x, let's say, equals negative 2 x plus 1 squared minus 4. And you can say, I have no secrets here. I know this. I don't have to do anything. I've done this before, last week. So what is this? It's x squared, shifted where? To your, how many? Perfect. And then stretched by factor of, correct. And then, what is the vertex then? One more time. X squared, left 1, stretched, reflected, down 4. What is the vertex? That's it. It's right here. So the vertex is that h comma k. In this case, negative 1 comma negative 4. We don't need any effort here, right? We're not going to make any effort. We know this. But let's go through the same steps. Can anyone give us the range? We haven't even graphed anything. Can anyone give us the range? Negative infinity to negative 4. Very good. Awesome. And we haven't done anything. I just looked silly with my arms up and down. Perfect. So let's go through all the steps. Shape. Max or min? Right, because of this is the leading coefficient. A equals negative 2 is less than 0, so the quadratic function or the parabola has a maximum. Very good. Number 2, there is no effort for the vertex because the square is completed. And I know how to graph this, and I know how to find the vertex with no effort. No calculations are needed. Very good. Number 3, X-Intercepts. Remember my silly explanation, right? 1 to the left, stretched, reflected, down 4. Will I find X-Intercept? X-Intercepts. None. The maximum is negative 4. The range is from negative infinity to negative 4. It doesn't even touch the x-axis. 4, Y-intercept. You have to be careful with this form because the y-intercept is slightly more difficult. So I have to find f of 0, right? How much is 0 plus 1? How much is 1 squared? 1. How much is 1 times negative 2? How much is negative 2 minus 4? Negative 6. So slightly more difficult than just plugging in 0, 0 and get a number. So 0, negative 6. And 5, 6, and 7 are just words. You already gave me number 7. What is the range? One more time. Negative infinity to? Great job. And number 5, the axis of symmetry. X equals? Very good. And the max, because it has a max, is? That's it. So the first one took us like, I don't know, 7 minutes, and this one took us like 1.5 minutes because it didn't need any calculations. We knew all this from last week. Okay, let's graph it. Yes, Becca, sorry.
The axis of symmetry
is always the vertical line going through the vertex.
So the x.
X equals negative, exactly, yes, always. And the minimum or maximum is always the y-coordinate of the vertex. So let's graph this. Now, if you need more examples, please stop me and say, I need another example, and we'll do another. So, negative 1, negative 4, the vertex, axis of symmetry, x equals negative 1, and I only have 0, comma negative 6. So this was 4, 5, 6. You can say, are 2 points enough to graph a quadratic function? No, they're not. But symmetric on the other side, I can always determine another one, as long as they are 1 unit apart. And now I have the graph of -2, x plus 1 squared minus 4. Any questions? Now, I'm more than happy to do another word problem if you'd like, or other graphs. What would you prefer? Okay, so let's look at 68. I'm sorry, 361. So you have 80 yards of fencing to enclose a rectangular garden. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So we have 80 yards of fencing to enclose a rectangular region, garden. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So 68 on 361. Yes, thank you, thank you. Sorry about that. Okay, so first of all, I know that we have 80 yards. And we assume we want to use it all. And we want to create a rectangular garden. We do not know the dimensions of the garden. We want to use this entire length of the fencing we have. And at the same time, we want to maximize area. So we have several options, right? This is one option, here's another option, and so on and so forth. But we don't want specifically to have a maximum possible area using the entire length of 80 yards. And this is a rectangle, so I'm going to say this is x and this is y. And can anyone give us an equation? That's the area. That's perfect. That's all I wanted for now. X times y, this is the area. Length times width. But there is something else that we want to write using the 80 yards. Yes?
Yeah, 2x plus 2y.
Equals? Excellent. Yes. 2x plus 2y equals 80. We start here, we go all around, and we're using the 80 yards. So obviously 2 times x times 2 plus 2 times y. I will divide both sides by 2 because I want to simplify the equation. So we are asked to find the maximum area. So this is my area. This is my function. But I can have two variables in the function. This is not the y that represents the function. This is a totally different y. It's the width. So this is the length and this is the width. So I need to get rid of one of these two. How can I do that? So that I have an equation only in x, for example, or a function. This is like f of x. I will call it a of x because it's the area. But you can call it f of x. It doesn't matter. Is there a way of getting rid of this y from here? And no, because this is the function. I cannot move this to the other side. This is the function. This is just x times y. But I have to use what I'm given. So what should I do with this to make the y disappear? Yes, indeed. So y equals negative x plus 40. And now this is the way I get rid of y. So then I copy the x. Instead of y, I copy what it equals to. And that is negative x plus 10. So I use the given information that the perimeter, if you want, of this rectangular region or area or garden is 80 yards. So I removed y from there. Yes?
Plus 40.
Oh, I wrote 10? Oh. I'm sorry. Thank you. Sorry. Thank you. I wrote 40 here, but I copied 10. Thank you. So then the area A of x is negative x squared plus 40x. And now I'm looking at this, and I'll say, oh, yeah, it makes sense. Well, what type of function is it? Of course. Does it have a max?
Yes.
It has a maximum because the leading coefficient is awesome. Okay, so now let's think again, or continue thinking. How do I determine the maximum of a quadratic function? I need to find? Exactly. That's all it is. And now you understand why I specifically insist that you add this in the problem when you graph. I'm gonna list for you these things. You don't have to memorize it, but I'm hoping that once you graph 2 or 3, then you will remember. But I'm gonna list them for you. This is extremely important because that will give you always the idea of what's happening with this function. Does it have a max or it has a min? What's happening with it? Okay, good. So you told me to determine the vertex. Let's determine the vertex. How do I determine the vertex? Correct. Negative b over 2a. Negative. What is b here? B is 40. And 2 times a is? Negative 2. So the answer is, it better be a positive number, 20. So the length, this piece is 20 feet. How much is this? No problem, because I have it here. If the length is 20 feet, 20 indeed. And you may remember this from geometry. The rectangle with the maximum area is always a square. It's 20 by 20. Okay, so now we know that x is 20 feet. We know that y is 20 feet. But we also want to determine the area. This is the vertex, right? 20 for x, a of 20 in here. But I don't need to calculate it because I know how I determine this. It's x times y. And I have x and I have y. So what will the answer be? 400. Right? 20 times 20. X times y. If you go back here and you replace x by 20, what do you think you're going to get? Absolutely. You're going to get the same thing. Any questions about this situation before we look at another? Yes. I'm sorry?
One that required us to go random.
Yeah. So, do you want me to just create another function to solve it and find the x-intercepts? Okay, so there is one here, negative 0.04 x squared plus 2.1x plus 6.1 equals 0. So let's say we want to determine the x-intercepts or find the solutions, in other words. Again, you should always refuse to solve a quadratic equation with a negative leading coefficient. So let's multiply both sides by negative 1. 0.04 x squared minus 2.1x minus 6.1 equals 0. Is this okay so far, everyone? And then with the quadratic formula, negative b 2.1 plus or minus the square root of 2.1 squared minus, there is another minus, so plus 4 times a and times c over 2 times a, 0.08. I strongly recommend do not determine these numbers piece by piece.
Water outage. Water in Arnold campus will be not functioning for approximately 45 minutes. Campus will remain open through this period. Water outage. Water in Arnold campus will be not.
Okay. Yes, please.
I know where that 0.04 comes from, but.
It's the formula. Negative b plus or minus the square of b squared minus 4ac over 2a.
So what
I'm
would
taking
the-
That's okay.
Wouldn't the 2.1 be a negative?
So the formula has a negative and one of these two numbers is negative. That's why I already changed it into positive.
And the first, like the 2.1 squared, wouldn't it be negative?
Okay, very good. So remember when we talked about the quadratic formula, I said if I see a negative here, I cross out the whole thing. I can't give any credit. No matter what number you have, when you square it, it will always be a positive number. So if I see here a negative, so please remember, I don't want to see under the square root anything starting with a negative number because that is squared. If it is squared, you have to write positive.
But you can put in parentheses.
You can put in parentheses. You can. So please be careful. Okay, so let's calculate that. So left parenthesis for the numerator, 2.1 plus the square root, parentheses, 2.1 squared, plus 4 times 0.04 times 6.1. Outside, close the parenthesis, and divide by 0.08. I copy to get the -1. It's easier for you with second and entry to go back. I have to go, maybe there's another way, but I don't know it. Minus. Okay, so the two options are x equals 55.26 and x equals -2.76. Is this better? Other questions? Is there anything that you would like to go back to before we choose another word problem? Anything? Thank you for asking that, because every question, I'm sure it's probably on more than one mind. And if you ask, you help me and you help everyone else. Okay, so let's look at 64 on 361. Among all pairs of numbers, can you give me two numbers, not the actual number, variables? X and? Good. Among all pairs of numbers whose difference is 24, come up with an equation for us. The difference is 24. Great job. Find a pair whose product, can anyone give us the product of these two? Very good, awesome. So find a pair whose product is as small as possible. And what is the minimum product? Any suggestions? Say it again. So we have a function, so we want to find the minimum of this function, but we have two variables in it. So somehow we have to get rid of one. We prefer getting rid of y. It doesn't really matter. But how can I get rid of y? Solve this equation for y. Negative y equals negative x plus 24, and then y equals x minus 24. And therefore, I will replace y like we did 3 minutes ago by x minus 24. As you see, there is a pattern. I'm sure you see the pattern already. So the new function, or the function we have, is p of x now, just x in it. And we have x and x minus 24. After we distribute, we get x squared minus 24x. And we're asked, and you tell me whether it makes sense or not, does it have a minimum or a maximum? Correct. So we are looking for a minimum. So what do we have to determine? Indeed, because it's a quadratic function. Very good. So how do I determine the vertex, the x-coordinate first? because I can't find the y before I find the x.
Vertex 1.
Negative b over 2a, negative 24 divided by 2, and I get 12. So if x is 12, can anyone give us the y, the other number, not the product, the other number?
Wouldn't it be negative?
Very good. I'm sorry?
No, wouldn't x be negative 12? Negative 24
Multiplied by negative 1.
Oh, the other negative, okay, sorry.
That's okay, no problem. Is it, have we resolved the question? Have we answered the question then?
Yeah. Sorry,
Okay.
I missed it.
That's okay.
Negative 12.
So if x is 12, how much is y? Negative 12. And now please give me the product. Or you go back with this 12 and evaluate the function. But it's easier if I just determine the product. Negative 144. So the two numbers whose product is minimum and whose difference is 24 are 12 and negative 12. So the two numbers whose product is minimum and whose difference is 24, they are 12 and negative 12. Any questions? Sure. Among all pairs so this is 61 on 361. Among all pairs of numbers whose sum is 16. X plus y equals 16. Very good. Find a pair whose product is as large as possible. Can anyone give us the product? Very good. And we want to maximize that. So what do we do next? I don't have a function yet. If I don't have a function, I can't find the vertex. Very good. Y will be negative x plus 16, and this will replace the y. So p of x indeed is the function. And this is x and negative x plus 16, and this is negative x squared plus 16x. Now I have the function. So I do have it, and now I can continue. How do I continue? Yes, awesome. So we have to find the vertex. How do I find the x-coordinate of the vertex? Very good, awesome. Negative b is 16, 2 times a is negative 2, so the first number is 8. So let's find the y. So x is 8. From here, how much is y? Very good. And now the product.
64.
So the maximum product of two numbers whose sum is 16 is 64. Feeling a little bit better about this one?
Yeah.
Any questions? Yes, please, Becca.
So once you find x,
Yes,
you have to plug it into y equals.
if you want to. Oh, yeah. To find the other one, because I'm asked to find two numbers. But I'm also asked to find the maximum product.
So you have to plug into the y equals and then that plug that into.
Yeah, because the product is x times y. But if I replace it here, I will get the same thing. It's negative 64 plus 18 times 6. I will still get 64. But it's easier because once I determine x and I have y, the product is this. That's how I got this function from the product. So this function or this function mean the same thing. So it's easier to say 8 times 8 is 64 than to go back here and determine p of 8, which is negative 64 plus 16 times 8. So this is negative 64 plus 128, and when I subtract, I get 64. Because this is the original function. I changed it into this.
I think what she was really confused about was finding y.
But we have, you mean from here? Solving this one for y? Is that the question?
I don't think she was asking.
We should grab this P of X.
Right, no, my question was once you found X, you can maybe put
How you find the product?
right, you can
Yeah.
either put it X times Y or put it in the P of that.
Exactly. It doesn't matter. It's up to you. Well, when we graphed before, right, that's what we did. So in all these situations, how did we find the y-coordinate of the vertex? We just went back to plug it in the function. That's what we did. But here, since I have the two numbers that make that function, I find it easier to just plug it in. Just instead of plug it in, just multiply those two. Any questions? Any questions? Are we okay now with this? Okay.